Okay. Okay, let's get started. Hello, hello. Okay, good afternoon. Welcome on a nice rainy day. Okay, so we're going to be moving, today we'll be moving past basic programming, Rebecca, and moving on to arrays. But first of all, I would like to take up the homework and explain how I will be doing the homework, and then so you can understand how my thinking towards the homework would be and why I made the decisions I did. After that, we'll do some theory on the arrays. After that, we probably will have some time for milestones, and then we will then do some more time on arrays. Okay, so I want to get as much as we can of the arrays done so people can do the array milestone next week, those who are working on that milestone. Okay, we will not do the array milestone today, we will do it next week though. Okay, so the last milestone, so we'll have the opportunity to do that next week. So today's class basically is this. Okay, I hope to first of all take up the homework. In other words, I want to show you how we used, just to take up that, so that's page 47 in your book, your homework from last week. So hopefully hopefully you'll be able to, as you look at it, and it'll help you to improve your thinking. And so that's basically our first goal. Second goal will be introducing arrays as a data structure. Why do we need them? We will then take a break. We will then have probably the next hour we'll be retiring milestone, because I think milestone 5 takes a fair bit of time to do, so that's why we'll have a longer period of time for milestones today. And then after the break we'll start on theory section 3, arrays as data structures. And your homework, one part of the homework, remember the textbooks are all in the library, so you can just use the electronic version. Please read the chapters in the textbooks. Don't just rely on the workbook. If you're just, because yeah, I think there's 2 versions of the textbook, and they're all ebooks, so it's quite easy to do. So the ebook chapters we're working on. So section 2.1 and section 2.2 will cover arrays, and if you want to go on to records, you could do section 2.3. Okay, and obviously section 1 is carrying variables and pointers and the basic programming we've been looking at before. Okay, so that's all covered. So do continue to use the textbook and make use of it. All right, so our first step is to start to take up the homework, and then next week we'll continue on with arrays. We'll show the arrays using it for the following object application, and we'll probably have another chance to do milestones, and same thing, and we'll continue on each week with one chance to do milestones. Okay? All right. Any questions? Rebecca, are you clear? Rebecca? Pardon? Maybe. Okay, fair enough. Okay. Close enough. Close enough. Maybe is a good answer. I like it. All right. Okay. Let's move now to let's go back to see the root problem and introducing. Okay. All right. So remember what we've been trying to do. Let's go. We're wanting to find the square root of p. Okay? And we wanted to try. So far what we've done is this code, right? We get small number, big number, and we manually enter XBS and XB each time we run it. This is really stupid and boring. The computer should be deciding what next to try next. So we need to automate with repetition. And so basically now we're going to be making this. And so the key thing first we have to do that is to modify the UML. All right? So our current UML is basically this guy. I fixed what p was going to be, so what I wanted to take the square root of. We just always did square root of 2, but now we're going to generalize it. so we can take the square root of anything. We inputted the number that was too small and too big. We calculate what was halfway between. We calculate y minus x squared minus p, and then based on that, we output that, and then we try to decide what our next s and next b would be for our next time to run it. So we don't want to do that. Rather, okay, these guys we use get float prompt for. This one we created a function cmean. This one we used the function equation we wrote. This one we used the function fprintf. Okay, so that's the movement to the functions. And our overall function was main, which called these subfunctions. Now what we want to do is switch to this now. Now we're going to input the number we want to get the square root of. We're also going to input how accurately we want it to be, how precise, subject to p greater than 1. We will then start, because we know 1 is too small and we know p is too big. So we'll just start at the biggest and something that's too big and something that's too small, because it won't change the time of the program very much. Okay, this program will find these to start, and then it will check, is b minus s greater than epsilon? If the big end is minus small end is bigger than epsilon, we have to get closer to the root. We will then find the x halfway through, y, then we have to make the decision. Is y less than 0? If that's true, then small should be x, and b, otherwise, b, we take the value of x and we make that b, and we'll continue on looping until we finish, and finally we'll output our final result. Okay, so let's start programming. I think I'm going to start from the pointer version. Do I want to start from that, or let's start from the variable version this time for fun. I think I start open with okay, edit with notepad, okay. All right, where did it go? Here we are. Okay, here's our existing code. This is the variable one. I'm not going to start with the pointer one. Okay, let's start look again. We want to look what we want to do. Let's file save as. Okay, this PC, SDBA, and this will be our root, C root. .c, okay, and all right. What else do I want to do in this algorithm? Okay, after I know my algorithm, I've got my starting code here that we did before with the two functions. I'm not going to change these functions, so I'm going to keep them. So I'll just throw them down here. So ultimately, I should decide on what functions I'm going to use before I code. So I'm going to keep cmean. I'm going to keep equation. I'm going to keep fprintf. So that part of the code I'm going to keep. Okay, those functions I will keep. I will use get prompt to get p, and I'll create a new function croot to call these functions to do this. So I've done all this without coding. Okay, so this is all pre-coded. Now let's move to C code. Okay, I got him over here. Okay, first things first is the input. Okay, I want to input precision. I don't care anything about, okay, input precision. Let's get the two things through, P and EPS. I'll call those the things, okay? P, get float prompt. What do you want? Number to get, I want the square root of, I don't know, what do you want? Square root of number to get square root. Number to get square root. Okay, so I've got my, okay, I have what I want, okay, and EPS, I'll make how accurate. Or how accurate do you want it? I.e., how many decimal places? Okay, but I'll just leave that there. How accurate? Okay, now according to my diagram here, I'm going to call C root to get it. Okay, so this no longer gets here, so C root. So my square root is going to be, let's call it, my square root is always y, right? So y equals C root of, what do I need to give it? I need to give it P, what I want the square root of, and EPS. Oops, spelling mistake. Okay. And this is not going to go here anymore, so I'm going to get rid of it, right? Because it's not called from main anymore. It's being called from C root. In my diagram, I said a C root is going to call it. Okay. All right, let's get these out of here. Control X, Control V, and print. The fprintf is just going to change now. I want the, basically just square root of %LF equals %LF. So this will be P and Y. Okay, and okay, my main program is now finished, right? I'm getting the number I want the square root of. I'm getting how much error I can have. I'm calling a function to do the square root. Oops, don't forget that. And then I'm printing the result. So I've got a new function here I'm going to make a definition of, so I've got to get a prototype. So double, it's going to return a double. And it's going to take two doubles, right? C root double P double EPS, I guess, or E. I just call it E. Make it shorter for me. Okay? So there's my prototype. Now I've got to write C root function. Okay. C root function. Okay, what other variables do I not need here? Well, I'm not using S and B here anymore, so might as well get rid of those. I'm not using X, so he gets rid of there. I'm just using three variables here. Now I'm going to write my function C root. What do I need in him? Okay, I'm going to need, okay, C root's got an S and a B. Okay, so double S comma B. All right, and what? And I can initialize them at the same time. S equals 1, B equals P. All right, so I've just, okay, fair enough. I've initialized them right at the very beginning, so I've completed the initialization and declaration. Okay, I better move my, now I can't see what I'm doing. Okay. Okay, let's look at this thing. Okay. This is obviously, you can see here, there's only one diamond, right? These guys are in a pair. This guy's by himself, so you know it's a while loop. So this is while B minus S. Just put them in brackets. It's nicer. It makes it look more nice format. Not necessary though. Is greater than E. Okay, so I've now got the loop. As long as it's greater than this, what do I want to do? I want to call C mean with S and B, calculate X, and my equation. Okay, let's move these guys up here now. Oh, Control Z. Okay, there we go. I just want to move these guys up. Okay, he's up. X calculates the mean, Y calculates the equation, but it's not 2 I'm taking the square root of anymore. It's whatever P was, so I'll just put P here. Okay, P goes there. All right, and I got my X. That means I need two more variables here, x comma y. Okay, and I've done my calculation, so I'm now done at the if statement, right? There's two diamonds, so this is an if. If y less than 0, okay, and what do I want to do? S equals x, else, remember I can only label one, b equals x. Okay, so it's an if else, means you do one, then it comes back together again, and end of my while loop. So this will keep going. Then I need to return the answer, which is b minus s less than x, should be x. Okay, and this should be basic, the whole program. So you can get an idea of how the computer functions. Okay, now let's go down and run the program. Make sure it runs, find what errors I've got in it this time again. GCC minus C minus wall C root dot C. Oh, no errors. Okay, wow. I'm so happy. C root dot O, and I'm using J in live, so I've got to put in here J in lab dot O. Uh-oh. What did I forget? Telling it it's object files, right? Okay. Alright, so now C root. What do I want the number to be the square root of? Let's get the square root of 2. How accurate do I want it? 0.001. And that's the, okay, so now it calculates it. C root. What number do I want to get it? Number square root. Let's say 4. Okay. How accurate do I want it? 0.001. Okay, and you see the square root of 4 is 2.000031. Okay, so you can see it's accurate to 4 decimal places, right? And there's some mistakes at the very end. Okay, but if I wanted a higher decimal place, C root 4, 0. Okay, now this will take much longer to run, probably quite a while to run, since we've got so many decimal places. Maybe I've got too many. Uh-oh. Yikes, too many. Okay, Control C, let's do a simple. Maybe I've added too many decimal places. Square root of 3, 0.0, let's make it more normal. Okay, all right. So as you can see, obviously the more decimal places you take, the longer it's going to be. This one is still how many decimal places? I don't quite. And it doesn't really make any difference because I haven't showed how to print this out yet. So if I want more than 6 decimal places, I have to go up here into the formatting statement when I give my output. Square root of is percent maybe 0.20 LF if I want 20 decimal places. Okay, let's try that. Oops. C. Uh-oh, too many. Yikes. Okay, oops, what did I forget? G. Okay. All right, and I think we did that correct. Let's see. Oh, okay, I didn't get it wrong. Okay, let's see. Root, square root of 3.0001. Okay, and you can see we now have that many decimal places, but not that accurate. Try again. I can sort of play with this, see how many decimal places I can get before it's too slow. Uh-oh. Okay, this is going to be too slow. Forget it. All right. So the more decimal places, it really slows down a lot, this algorithm. Okay? Now, let's look at how you can, there's a few ways you could always speed this up, right? If you don't, you can speed up this program would be by reducing function calls. For example, you could do this. Forget the equation, just jam it straight in. Okay? Second way would be to forget this equation, jam it straight in. Okay, so this is basically how it would most likely be done on regular computer when it's calculating the square root. It's all just put into one function. You wouldn't bother, no need to bother with these other functions. Okay, so that's nice, short, a call for a C root function, and this function is what you will find in if you include math.h, this function is called square root. Okay, so and it takes the square root of p. Yeah, so you could do x equals square root of p. So this is the function that, whether you're using C, Python, or any language, would be written something like this. Okay? I think that should be sufficient on the square rooting. Okay. And no, I don't want to save it. Okay? Finished? Finished. All right. And there's just a few comments, the main program, and then we created the C code. Okay. You worked on that before. We were starting from the R var. Okay? All right. Now, let's walk through the code, and we'll see how this version that I did here before runs. I think it's basically the same, except for the fact, in this case, I say I always want e to the minus 10. Okay. All right. Let's analyze the code. All right. First two lines, information for the user, right? Just for you, so you know what the program's doing. Okay. Next two lines are the preprocessor locations. Okay, the prototypes. stdio.h with the angle brackets is a library function. The SDO, the other one with the brackets, is a function that is not standard. Okay. Here, this is another preprocessor command. So it's before the compiler runs. It replaces EPS everywhere in your code with 1 e to the minus 10. So generally in code you don't want numbers. Morris, problem? You're lost. Okay. All right. These are the key function prototypes in this file: C root, C mean, and the equation. After our function prototypes, now comes the main function. Okay. We initialize the main function, and again it tells me get nothing from the operating system and return an integer to the operating system. Okay. All right. I have two variables, p and root, declared. Okay, only two this time. And my next line says, okay, calls get flow point for what I want to get the square root of. And as you can see, I typed in 3, for example, and I should get 3 in the root. Okay, sorry about that. Okay, now I call C root with the 3. Okay, again, as you see, okay, and we'll start the program. It clears xy, xs equals 1, and xb equals p. Okay, so we have 1 and 3 in our too small, too big, and we check. Is xb minus xs greater than epsilon? The answer is no, so we enter the loop. We calculate the mean, which is 1 plus 3, 4 divided by 2 is 2. Okay, do the calculation, we find, when we do the calculation, we get 1, all right, which is positive. We check, is y less than 0? The answer is no, so we're going to do the else statement. xb equals x. Loop again. Is xb minus s greater than epsilon? Yes. Enter the loop. We take the mean. What's halfway between 1 and 2? 1.5, right? We calculate the equation and find that y is negative this time. That means y is less than 0, so xs equals x. Okay, so we have the lower bound now. So the final root is between 1.5 and 2. We'll repeat again. It's still greater than epsilon, but let's assume it wasn't. And we'll jump back. We jump back. We go to return. And we then print out, call fprintf, do the printing. And the root is printed at the bottom as 1.5. And we return, leaving there. So, and main disappears and it leaves stuff in memory. Okay, so the memory's now been changed. Okay. I hope that should be okay. Let's now move on and start. Our next step is to start talking about, arrays.